Hello and welcome to the last lab talk in our four-part series to help you master cold storage. My name is Wilfredo Marin, Senior Product Application Specialist focused on cryopreservation and biobanking. We've got some great resources for you to download in one of the boxes on your screen, and I highly encourage everyone to explore the Discovery Expo, where you can complete your passport to science and qualify to receive a set of building blocks. So if you've made it this far, I sincerely thank you and understand that you're heavily invested in maximizing the efficiency and performance of your equipment to enable your research. If you'd like to get caught up, the previous lab talk sessions, recordings, including sustainability, ULT performance, optimal sample storage temperatures, are available via the links in your registration email. So today I'll be sharing some very important and specific best practice information applicable to many research and clinical settings. Again, I'm drawing from my many years in a laboratory, not really wanting to worry about freezers, but understanding that certain maintenance or settings can help with the overall sample integrity. So I'll start with how you can take a moment to self-assess your facility, what to look for, and where to find best practices. Then I have one example of looking to pursue certification of a biobank with the College of American Pathologists, or CAP, and what that checklist looks like. I have a final slide to walk through some preventive maintenance items in detail for the TSX Universal Series ULT. And lastly, I'll invite our special guest, Jason Nikolazakis, the Connected Solutions Commercial Manager and our remote monitoring guru for cold storage. We'll both stick around for Q&A at the end. So I wanted to share this slide, not really as a scare tactic, but with the optimism that a situation like this should no longer exist. We've come a long way from dealing with the lack of innovation for cold storage in order to overcome our customers' challenges. So while this talk is fairly short and it speaks more about equipment maintenance, understanding those improvements, like minimizing frost buildup or proper use of rack accessories, will help facilitate how to properly identify, store, and access the samples as well as their data. Taking that into consideration, we still have to challenge ourselves and what it means to be successful in the future. And it takes an honest assessment of our current activities. I've been in these environments. There's a lot of pressure or turnover for technicians. There's insufficient time or training, which makes everyone prone to mistakes. One of the most important things I could do is ask for guidance. And it's one of the main reasons to provide this short lab talk, bringing the experts to you. This also means relying on best practices for your process and equipment recommendations. So the first point here shows infrastructure and operations. And I'm showing ISBR in appreciation of their 5th best practices, which was released last December and includes great topics for facilities of all types and sizes. ISBR stands for the International Society of Biological and Environmental Repositories, and they offer a qualification in Biorepository Sciences, or QBRS, through the American Society for Clinical Pathology. NCI, or National Cancer Institute, also offers best practices and protocols for specific sample types. And I regularly receive updates from them about papers or protocols that were submitted and are of interest. So I'm very happy to shout them out because these are experts looking to provide additional guidance to the community. But what this really means is that even before reaching a freezer, we're aiming to control the consistency of the sample acquisition. And part of having an experimental plan is being able to adapt quickly and fulfill that work. Most important in having a larger facility emergency response plan is that this is not necessarily about an unlikely event because there are enough natural disasters and geopolitical disruptions that can vanish decades of overnight. This is an incredibly necessary part of creating a sustainable laboratory. And lastly, for this slide, it's really important to be transparent about the contributions and accomplishments. It's very helpful to share and amplify all the successes of your data generation. This leads to more opportunities, so people have confidence in you and the results of your research. So what is the type of accreditation that we're looking for? Well, if you're trying to modernize a research facility where it plays a larger role in healthcare, it's possible to find additional regulatory guidance. So this example, through the College of American Pathologists accreditation programs, provides an engaging, dynamic, and collaborative process that fosters an environment of continuous improvement. The description of the program is designed specifically for biorepositories because they're collecting, processing, storing, and distributing biospecimens for research. And in total, CAP accredits more than 8,000 laboratories worldwide, with more than 600 outside the US in 60 countries. The program, at least this one, the BAP, was developed and introduced in 2011, and it was the first of its kind for biobanks. It's a 3-year program. The first year, you're establishing the application process and the initial on-site inspection. And the second year is kind of like that self-assessment. It's a self-inspection, with the third year including a customized consult or CAP staff-led overview. So the goal is to provide requirements for standardization and biorepository processes. And hopefully this will result in high quality specimens that can be used to support your research, drug discovery, or personalized medicine. We're also looking at resource, process, and quality management. So here is a distinct, clear distinction of the laboratory roles and responsibilities, which has to be communicated and completed on a regular type of schedule. All that probably generates a lot of documents, a paper trail. And so because this is primarily focused on equipment, we're looking at temperature monitoring specifically and handling of biospecimens for both short and long-term storage. So the checklist for BAP is really interesting. It comes from the accreditation manual from 2003 or 2023, and it has about 178 requirements. Only 4 were recently updated in 2022. And these are requirements for items that might seriously impact the quality of services, endanger patients, clients, or personnel, and they impact regulatory compliance. So these citations are going to require a written response of compliance and supporting documentation prior to accreditation. So one of the first points in that checklist is a section for specimen storage, which lends itself to fit for purpose equipment. So users should really understand the options that will remain best, will best remain with reliable temperature performance. So one of the clauses here I listed to identify the critical data impacting quality is 07800. When we're talking about storage equipment, calibration, and calibration verification, storage equipment. And what it's asking is that you include the date the calibration was performed, the identity of who ran the calibration, records of the results, as well as the device that was used against calibration or the instrument to be calibrated. All this is part of the evidence of compliance. The second clause here that I'm pointing out is remote alarms and preventive maintenance. So this is when temperatures are being checked and recorded on each day of use, and it's specifying which unit and location for all the temperature-dependent instruments and equipment. So again, these are just 2 of the 178 clauses that are in that checklist. And if you'd like more information, I've cited the checklist as well as the manual in my slides. So lastly, I'm going to spend a little time on this slide because it really merits the walkthrough of equipment efficiency. And pictured here is a TSX Universal Series ultra-low temperature freezer and preventive maintenance recommendations from the manual. So I highly recommend and encourage everyone to always keep the manual as well as that technical data sheet readily available along with the inventory for every unit. But when we're talking about innovation and touchscreens, we start with the UI that's on this unit. And best practice suggests that there be a constant temperature monitoring, even potential status indicators, such as we have the green light bar or a green heart, and there's constant temperature monitoring so that you have the ability to retrieve the data during a certain course of time. And we can do that. We offer it here on the UI with the use of the USB. We've also improved the startup of the UI wizard to help ensure it's easier to understand, as well as set up with the proper set point. So these guides are even stickered onto the side of the unit for all lab personnel to view. And ultimately, this information is intended to simplify training and save you time as well as money. But there's some things that scientists aren't really interested in doing or can't do it because the reality is that they're busy with experimental data, which is far more important. So in this checklist of the manual or preventive maintenance periodic intervals, we do consider that the unit should be in optimal environments. They are quiet. They do have minimal heat load rejection into the facilities, but that's best accomplished by checking the filters that are behind this grate, as well as checking any dust and cleaning anything off from the condensers. That can be done at a period of every 2 to 3 months. As we open the door and we keep we actually use the unit gaskets, wiping off any type of moisture. We have some guidance on how to do that and why to check that so that you have a proper closing of the door, as well as once we open the door, we're looking at the shelving and we're making sure that anytime you're opening the door, you're really what you're trying to do is open up that section, that compartment, whether it's top or bottom with this two-door system. So these units also have a larger pressure equalization port, which means that you can re-enter unit very quickly after opening. So you might see a little frost on those door panels. But luckily for us, we have, in addition to supporting the remote monitoring section, we have additional ports for third party, both at the top and the bottom of the unit, close to the middle, where you can introduce some of the remote monitoring solutions you may hear next, as well as supporting some of the minimizing frost by including heater usage along the door. So again, that can be programmed on the easy to use UI, and you can just wipe that off. And we have some great time-lapse videos on YouTube to show you how long that would take. And I would seriously consider that when you are organizing all of your samples, you pay attention to the total weight that's putting on the shelves. We've heard that not all shelves from all competitors are the same. Some can withstand a little bit more weight than others and are built for more regulatory type usages. But we do offer a variety of rack accessories for your layouts and your sample organization and maintenance, as well as some of those fiberboard boxes, so you can organize every sample and of course minimize the time that you're spending inside. So hopefully you've heard some of the preventive maintenance options or guidelines that you can use to follow. One of the last things I want to mention is that one of the best ways to maintain this performance is to regularly monitor your units or your multiple units. And so I'm really excited to introduce Jason Nikolazakis, who can talk more about our remote monitoring solutions when using some of the TSX Universal Series ULTs.
Thank you very much, Will. My name is Jason Nikolazakis, and I'm the Global Commercial Manager for Remote Monitoring Connected Solutions at Thermo Fisher. Will had invited me here to discuss the importance of remote monitoring, and more importantly, what considerations should you have when looking into a system? There's many systems out there, and so what kinds of things should we think about? Well, first, I think it's important to look at perspectives. There's really two, and actually maybe a little bit more, and I'll go into that in a second. First is the sample protection perspective. This essentially is what you're going to use the system for. Sample protection perspective is through the eyes of a user or a PI, perhaps a lab manager or a program director. They want to protect the samples that are being stored inside the cold storage units, no matter what. They want instant alerts if there's an issue, and they want the confidence in knowing that these items, these samples are protected. In addition, there's also another perspective when it comes to remote monitoring, and that's device and fleet management. Now, with device and fleet management, you're looking through the eyes of the biomed group, or perhaps facilities, or even QA/QC. These are people that want to maintain the freezers or the equipment, the assets, the devices. They want to not buy new ones as often. They want to prolong the lifespan of these units. They also want to make data-based repair and replace decisions, as well as targeted maintenance, rather than wasting money on peanut butter spread maintenance that may or may not be effective. Also, it's important to take into consideration your facility's infrastructure. This is your network architecture, how things communicate, where things are being stored. For example, how's your Wi-Fi in your facility? Do you require an Ethernet connection? Is there perhaps a need for 4G cellular or even some sort of proprietary signal like LoWa, long-range wireless network? Are there any security considerations, or how about signal strength? Is your building made of sheet metal, or is your building made of thick adobe walls that nothing can penetrate? How much IT support do you have? Maybe you are the IT support. Is there a wired infrastructure in the building, or does that not exist? How much data are you going to need? What kind of plans are available? And then when it comes to costs of these systems, as you buy more and more and more, can one piece of equipment remote monitoring equipment handle multiple devices at a time, or is it one-to-one ratio, and what will that cost over time? Should you house your data and utilize a cloud infrastructure, or should you have your data stored locally or on-premise? When considering that, there might be software or subscription services to take into consideration. And again, security and technology updates to those services. Are there any computer requirements involved? And then again, storage capacity and location. And then devices themselves. Are they controlled by AC power, battery, power over Ethernet? What type of battery is it? How long is the life? How often are you going to be replacing those batteries? Is the infrastructure wired on premise available? All of these are very important when deciding what type of remote monitoring system might work for your facility. And then, of course, we've gone from paper wheels to end users walking around with a clipboard in the laboratory to remote monitoring system. And where we see this market going forward is actually integration. Can a remote monitoring system integrate with the programs and facilities management that you already have on site? Or is it more important for all of these items to be separate and manage each one of them independently? So on-site compatibility is a big deal. Does it communicate with your existing infrastructure? Or maybe you're just looking for basic monitoring, something completely independent and qualifiable. So on-site currently, do you have a building management system? Can it integrate with that? How about a security system, a Berg panel? Maybe you have a security personnel that monitor the facility when others are away. Is there a LIM system currently in use? Do your devices utilize OPCUA machine-to-machine protocol communication? Do you have a remote monitoring system that can communicate and integrate with that? Are dry contacts necessary for, let's say, a security Berg panel or other monitoring devices with the building management system, such as flood control, door openings? Are 420 milliamp contacts necessary? These would be instead of using independent sensors into equipment that can't facilitate that. How about serial connections? And what I mean by this is think about your car. Think about the OBD sensor underneath your dashboard. And you can plug a device into that and you can see everything the car sees. Well, as Will had talked about with the new TSX Universal Freezer, we have the serial connections along with other Thermo Fisher devices that you can actually just plug into the back of it. And you can read all of the sensor data that the actual machine is reading itself. This is going to help you down the road for service capabilities. Instead of having actual service personnel come on site, you have a service ability to view your equipment from offsite and make recommendations, thereby saving you a lot of time and money. Or perhaps you're more interested in independent sensors, having that more over-the-top approach, something that's more qualifiable depending on your current protocol. And then any other additional considerations you might understand. Is there an app available? Is it utilized by the web? What type of platform or computer do I need? All of this needs to be taken into consideration. And then, of course, regulatory. Some things to consider when it comes to regulatory is data protection. What is protecting the data from getting out? Who has access to it? What type of privacy laws are needed to be taken into consideration? If there's a data breach, who gets a notification? Are you sending any data overseas or cross borders? Does that data need to be minimized? How long do you want to keep it? Who's accountable? What type of audit trail is needed? Is it 21 CFR Part 11 compliant? What type of documentation is needed? How are the reports? How often are the reports? Are they consistent? Is the data being housed by a third-party vendor? Is there a business continuity plan in place? And then, of course, any sector or industry-specific regulations are important to consider. Our advice, if we were to give one solid piece, is that it's a really good idea to have and involve your IT group early in the discussion. And then finally, scalability. What we find is what might be really good for you today may not necessarily be good for where your organization is going. So you have to take future phases and expansions into consideration. Perhaps multiple sites. What does that organizational structure look like? Who's going to be able to have access to it, and what are they going to be able to see? So taking all of these things into consideration, you will be able to have a good conversation on what remote monitoring system might be best for you. With that, I'd like to hand it back to Will, and I appreciate your time. Thank you.
Thank you, Jason, for explaining that in detail as it relates to our cold storage. So hopefully you've heard how you can excel with efficient equipment maintenance and some of the best practices from today. So now I want to make sure that you are aware that there are live demos available through our Learn Immersive Lab. And so make sure you can book that with our team to get a closer look at some of the equipment and how it's used in this environment. And now we'll open it up for Q&A.
All right. Before we jump into questions, I just wanted to say a special thank you to Wilfredo Marin and Jason Nikolazakis for sharing those insightful, helpful tips with us today. I'm actually in the immersive lab that Will mentioned. So this is a great place you can, if you ever want to see something further, we'd be happy to accommodate your demos with us. My name is Megan McDowell. I'll be moderating the live Q&A session today. And I have a special treat. You may remember Josh Lewis from our earlier lab talks. He'll be answering the ULT freezer questions today. So if you have any of those, make sure you put them in the chat. And if the remote monitoring piqued your interest, put those in the chat as well. This is your chance to ask Jason, our connectivity expert, anything that's on your mind. So let's jump right in. I see one question came in. The first one here is for Jason. And Jason, this is on the subject of remote monitoring systems. So this person wanted to know, how difficult are these systems to install? Is this something that they can do themselves?
This is a really good question. We do get this quite a bit. And I guess I would turn that around on the person asking the question, which is, how comfortable are you with IT? So a lot of our systems are designed to be self-installed, but we also have a lot of qualified personnel in our IAS division, our services division, to do these installations for you. We have a number of collateral available that can walk you through the installation process of a lot of these systems. But again, that's really a question of your comfortability level. If you're comfortable with doing it, we'll help you walk through it. If not, we're happy to take that on for you. Either way.
Great. Thanks, Jason. It's nice to have those options. Along the same line, we had someone else ask that they said they often run their monitoring wires through the outer door seal. How bad is that really? Is there another way they can install the wires? Josh, I'm going to bring you on actually to talk about this one.
Absolutely. No problem. So when you run remote monitoring wires through an outer door gasket seal of any kind of cold storage product, you're effectively creating a small air leak or a small gap in that door seal. So you're promoting kind of frost buildup and warm air entry into the cabinet. It is minor, but it is possible that you're going to see a buildup of frost or ice accumulate there. That's why in almost all of the cold storage equipment that we offer, and almost all those on the market, there are access ports in the rear of the product. We highly recommend using those when you run any kind of wiring.
Great. Thank you.
Mm-hmm.
And Jason, back to you for this next one. How easy are the remote monitoring systems to expand once they are in place?
This is another really good question. This kind of goes back to that scalability piece. So if you keep in mind your future phases of your organization when shopping for a remote monitoring system, it's really as simple as just buying the correct pieces of equipment and turning them on at that point. If you don't take into consideration those future phases and get the wrong system for those needs, then it could be as difficult as purchasing an entirely new system as you expand. So it's important to keep that scalability question in your mind where you want to go early on when you're doing your initial shopping. Great question.
Yeah, great advice there. Yeah. Josh, looks like a couple more for you about ULT freezers. So you had mentioned frost buildup. Is there any current features on ULTs to help reduce that frost buildup?
There are, and I think Will may have touched on it previously as well. Especially within our TSX Universal ULT freezers, we have an embedded door frame heater, excuse me. And that helps to mitigate that ice buildup in between the outer door gasket seals. And you can actually modulate how much current is run through that heater coil directly directly from our user interface. So if you're seeing buildup, you can increase it, and if you're not, you can decrease it. In addition to that, mainly using inner doors and making sure that any access ports that we mentioned previously are sealed. That's going to avoid a lot of the frost and ice accumulation.
Great. And someone else said they're afraid to use cleaners on and around the user interface. They're concerned with that might damage it. What do you think about that?
That's a really good one. I will definitely say, especially as user interfaces went to a capacitive touch, or kind of more like the touch screens on our iPhones, right? There's a lot more electronics behind the panel. I will say that from the thermoscientific engineering perspective, we actually do put a barrier in between our user interfaces and kind of any water that can get through potentially from cleaning agents. So in full transparency, I'd say we've tried it. We've tried to kill it. It doesn't work. So go ahead and use any approved cleaners that you want to.
Love it. You guys think of everything, Josh.
We try.
And I see one last question here. Someone said that they missed the beginning of the webinar. Yes, we will upload this recording to our YouTube channel, on Thermo Fisher Scientific's YouTube channel. We have a convenient playlist for Lab Talk, so you'll be able to go back, watch this episode, and every single Lab Talk episode prior to this, including our special edition series for cold storage. You'll also be able to access the recording from the link that you entered in after this call as well. But if you want to share it out with your friends, make sure that you check out our YouTube page. We do have the link in the resources section, so you can browse those other topics and see what other ones might interest you. But it looks like we've reached the end of the questions. So once again, really want to thank all of our presenters that have joined us for this special series on cold storage and best practices, or cold storage best practices and tips. Hope you found the information both interesting and informative, and perhaps you even went back to your lab and put some of these practices to use. So I would also encourage you, Will mentioned this at the beginning, but I'd really encourage you to explore the Discovery Expo in the resources section as well. You can really immerse yourself in a lot of the latest innovations from Thermo Fisher Scientific, including more information about the TSX Universal that we've talked about in this series. So make sure you check that out. And lastly, I just want to thank all of you for joining us. I hope you have a wonderful rest of your day, and we will see you next time.